Hey everybody, welcome to the Ionic Compounds Formulas and Naming video. This is meant to be a nice complement to your molecular compounds formulas and naming video that you just received. Now, ionic compounds. Let's think back for a moment. Our definition of compounds from Unit 1 was a combination of two or more atoms of different elements. The key there is of different elements. Now, NaCl represents both sodium and chloride in a ratio of 1 to 1. The formula shown at the bottom, NaCl, gives the ratio that you're going to find in the structure of an ionic compound known as a crystal lattice. It's a three-dimensional, regularly arranged crystal like the cube shown below to the right. Unlike molecular compounds, which we pictured more like cars on a highway, ionic compounds are locked in to this highly organized, regularly repeating structure, which keeps anions, in this case chloride in the green, next to the cations, or purple ions in the structure, and opposites attract. So we get attraction that holds together this crystal lattice. Now, how are we going to identify these or separate them from molecular formulas? Well, in ionic formulas, we're going to look for one of two things: polyatomic ions or a metal. In NaCl, we've got sodium, a metal, shows up in group 1, the far left of the periodic table. That nails this down as an ionic formula. In sodium nitrate, just to the right of that, we've got a polyatomic ion and a metal, both of which key this in as an ionic formula rather than a molecular formula. And finally, ammonium nitrate. While it doesn't have a metal, it has a pair of polyatomic ions. Now, these polyatomic ions are going to distinguish this as an ionic formula that we can use our ionic naming rules in coming up with a name for it. Now, what do we need to know and able to successfully pull off naming ionic compounds? Well, we need to know the elements off the periodic table, and you'll have a periodic table for this. We also need to memorize the formulas, names, and charges of all 10 required polyatomic ions. And finally, we need to know the typical charges of ions based on where they are in the periodic table. Based on columns, we can tell what the charge is going to be on a given element in an ionic formula. So let's look at a few shortcuts for this. Now, this is a blanked out periodic table, but we're going to write a few notes in it to give you an idea of charges that you can bank off of and typically depend on for elements in the table. Hydrogen, the alkali metals, come in with a +1. For beryllium and its column, we're going to come in with an overall +2 charge. Now, a special case is going to be aluminum. It doesn't apply to the whole row, but it's going to be considered a +3 ion. Nitrogen and everything below it comes in at -3. Oxygen and the chalcogens family at -2. Fluorine with -1 and everything below it with the halogens. And the inert or noble gases are going to come in with a charge of 0 overall. So you do want to memorize charge based on position in the table. Now, writing names based on a formula, we're going to read just like we would read a book. We're going to read left to right, and when no polyatomic ions are present, the first part of the name comes straight off the periodic table. The second part of the name, we're going to take the name right off the table, but change the ending to IDE. So Ki, shown below to the left, the first piece we come across is K, and K is potassium. The second piece that we come across is the I. The I is iodine, but we're going to change the ending, drop the INE, and replace it with an IDE, which is common in ionic compounds to end in that IDE unless we have a polyatomic ion. Now, a little bit of practice with this. CaF2, calcium being Ca, the first piece we come across, and F represents fluorine. Drop the ene, add the ide. We end up with calcium fluoride. Notice we didn't say difluoride. Di is for molecular compounds, prefixes we don't use for ionics. Al2O3, first piece we come across, aluminum. The next piece we come across is oxygen. We drop the -igen, the YGEN ending, and replace it with "ide", resulting in aluminum oxide. Now our job gets a bit easier as long as we've done our memorization if we have a polyatomic ion present in our ionic formula, something such as MgSO4. SO4 separated by parentheses is sulfate. So we put first magnesium, followed by sulfate. No IDE ending there. Next we've got K3PO4, K potassium, and our next piece, phosphate. Again, just end with the name of the polyatomic ion if we close with a polyatomic. Now going from name to formula, we name the cation first, and then we name the anion. We don't use prefixes, we use the charges instead, so we need to know the ratio of how many sodiums to how many chlorides inside the formula. And this is where memorization is going to make or break us in terms of how well we can do this. Now, NaCl, we get the element symbols off of the table, but the little question marks represent how many of each we need. A sodium being in group 1 has a +1 charge, and a chloride being with the halogens has a -1 charge based on where it is in the table. We want our formulas to add to 0. So if we take just one sodium and one chloride, we've got +1 and -1. They're going to add to a neutral overall charge, which gives us our formula NaCl. A couple more examples. First of which is aluminum nitrate. For aluminum nitrate, we read left to right. Aluminum starts it, nitrate finishes it. Aluminum, based on where it is in the table, is going to have a +3 charge, and nitrates, due to memorization from our list, have -1 charges. We'll need 3 nitrates for every single aluminum. So the resulting formula for this is going to be Al paired with 3 nitrates. Or we could say Al parentheses NO3 3, which gives us a fully balanced neutral chemical formula. Our second example, magnesium phosphate. Magnesium is in group 2, and magnesium has a +2 charge based on where it is in the table. Phosphate, due to memorization, is going to have a -3 charge. Again, we can't look this up on the periodic table because sadly it doesn't work that way. No shortcut for that other than brute force memorization. The lowest charge we can get them to agree to, if we have 3 magnesiums, that would give us a +6 overall charge. If we had 2 phosphates, when they multiply, that would give us a -6 overall charge. Then they would cancel. So we would need 3 magnesiums and 2 phosphates in order for this to be a balanced, neutral chemical formula. Well, that wraps up pretty much everything on going from name to formula and formula to name. Make sure you guys check out the assignment and check out the molecular formulas, naming, and formulas video. Thanks for watching along, guys.